Hi, and welcome to the Allplane podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, let me remind you once more that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv, Allplane.tv. Today, we welcome to the podcast Omer Bar-Yohay. Omer has been a leading force in the aviation innovation space for quite some time. In 2015, he co-founded eVTOL, an electric aircraft startup that we had here on the podcast just a few weeks ago. Omer left the eVTOL CEO role last year and then became president of AutoFlight, a truly interesting eVTOL project. AutoFlight stands out in the very competitive eVTOL space because of a couple of things. First, its global nature, with founders and production facilities in China, research, design and investors in Germany, and operations and testing in the US. Also, despite maybe appearing less often than some of its peers in the media and the headlines, AutoFlight has been hitting some pretty impressive milestones. For example, it recently set a new distance record by flying 250 kilometers on a single battery charge. And just a few days ago announced a really large order from a company called EVFLY. But more generally, I was also looking forward to speaking with Omer in order to get his insights about the eVTOL landscape and how he sees the technical and commercial perspectives for this new segment of the aviation industry. So, without further ado, let me welcome Omer to the podcast. Hello, Omer. How are you?
I am good. Thanks for having me today.
First of all, let me just tell the audience a few things about you, and maybe you can then complete giving us your your own perspective. You've been an entrepreneur in advanced air mobility and in new propulsion technologies for quite a while. I remember we spoke a few years ago when I was preparing an article about a new generation of light aircraft that was taking shape, and you were back then at eVTOL. Right now you are leading a different project, which is called AutoFlight, and it's an eVTOL. We're going to just talk about it in more detail now. But tell us a bit more about yourself, about your background and the background of this project.
Thanks, Mikhail. And yes, it was I would say it's a fun couple of years, almost a decade now. I think we're in a very interesting time in the aviation industry in general. And in a way, the electrification of many things in our world, in our lives, has been crawling towards the aviation industry for quite some time. And I've been fortunate enough through founding eVTOL Aircraft to be, some people will say front and center. I would say side and in the trenches. But yeah, I've been in these trenches for quite a while. But it's as I said before, it's a very exciting time. I'm a physicist by training. I love airplanes and electrical systems. And if someone was to tell me about 10 or 15 years ago, when I was still either studying or doing my early days work either as a physicist or in the auto industry, that one day the aerospace design space is going to be so diverse and will have so many exciting opportunities, I would have been very skeptical. I'm a very skeptical person by nature. And I think through my journey with eVTOL Aircraft and through the really phenomenal work that was done there by the team and building that, the Alice, the world's largest commuter aircraft that's all electric, I've learned a couple of truths, and some of them have to do with the required level of skepticism needed to really push these projects forward. But some of them also have to do with the fact that there are really hordes of amazing engineers and hardworking people trying to reinvent some of our modes of transport and to make them more accessible. And that's an exciting time to be. So I feel very fortunate. I'm a big skeptic of eVTOLs in general. I think a lot of people managed to mention this over the years, and I still am. But I think, if you're a skeptic, get your hands dirty, get to work. So I'm trying to push.
Mm-hmm. Yeah, indeed, there are two schools of thought here. There are some people that are absolutely enthusiastic about the possibilities of eVTOLs. We've got also some people on the podcast that are a lot more skeptical about the whole concept. But you're working now on an eVTOL, so I guess you can tell us a few things about what's going on and about the perspectives that you see for this new category of air mobility that is just now emerging. So after Aviation, you move on to AutoFlight, which is an eVTOL developer. What can you tell us about this company? I've read that you've raised $100 million of funding. Is that right? To develop
So
an eVTOL?
AutoFlight actually raised. So AutoFlight is a private company, so we're not talking about every aspect of the details of funding openly. But AutoFlight raised well north of 100 million. The last investment round was at the scale of 100 million and was led by Team Global. I think that was made public. But I think there are several things that are extremely interesting about AutoFlight and about where the space is heading in terms of I would say, global diversity, and in terms of building the kind of configurations that will make economic sense. And that goes back to the beginning of your question, or rather your comment about two schools of thought here, right? So people who are very skeptical compared to people who are very excited. I would think, at least to me, these are not mutually exclusive. You can be very skeptical, but still very excited. And I think that's kind of a healthy place to be in, because you want to build things that actually work. And when I'm looking at the eVTOL market, I was, I don't know if famously, but I was quoted as to saying, hey, you cannot sell a crippled R-44 for more than $4 million. And obviously referencing the Robinson helicopter. And that's actually true. That was part of one of my speeches in a conference about eVTOLs. And I still believe that. I think we're looking at a very, very unique niche that could grow to change the way we travel, but it needs a lot of things to happen to get there. And what I found is that you probably want to have the benefits of the electric propulsion, the benefits of the E in eVTOL, really at their peak, without the hurdles of significant reduced performance, and most importantly, at a reasonable price point. And I'll explain the concept and how does this relate to AutoFlight. So let's say you want to fly a mission over traffic in an urban area. So you want that mission to be fairly short, because that's the operating concept, right? You fly from the center of Manhattan to JFK or to Newark or something like that, which is a few dozens of miles. It's not hundreds of miles, and it takes several minutes, let's say under half an hour. Electric planes can do this, but so do helicopters. So why don't they? And the real answer is that helicopters that are cheap enough are not safe enough, and all helicopters are way too loud to do this. That's more or less the kind of core of the hurdle.
Why are they not safe?
So if you look at a single engine helicopter and the power to weight margins that it have, and you want to operate it very aggressively over a very densely populated area, if you do the math of what does 10 to the minus 7 or 10 to the minus 8 safety record mean over what is presumably an area that has hundreds of thousands of flights per year, and maybe even more than that, you're going to have 1 or 2 crashes a year. That's unacceptable. Mm-hmm. And the question is, okay, how does that translate to a safer means of transport? Because, our standards for aviation, especially commercial aviation, are extremely high in safety. Well, they translate to redundant systems, more power, the ability to operate in every, or in let's say, what we would consider very reasonable weather conditions in a city that are challenging for precise and very safe helicopter operations. That's kind of a Venn diagram that doesn't have a lot of areas that coincide. And then the question is, can eVTOLs fix it? And the answer is yes, but. Yeah. And the but is around redundancy, safety, power, and sound. Mm-hmm. And when you fix all of that, if you've had a configuration, I think some of the actors out there today have very, very capable configurations that could actually present a challenge to the reason why we don't see widespread helicopter operation today, meaning they build very safe platforms with a lot of redundancy, with enough power and enough time in the air to operate safely, not just to have one flight done safely, but to have the whole operation be constructed safely. And then the question is it affordable?
Yeah.
And
I was about to ask, there's also the cost dimension here, and helicopters are notoriously expensive.
Correct. So we all know the jokes about helicopters. It's not an airplane. It's a group of airplane parts flying in formation. They don't really fly. They get rejected by the earth. A victory of a triumph of engineering over common sense. Yeah. So helicopters are complex machines. And again, to make them safe, they have to be even more complex. And that makes them extremely expensive to operate and maintain. Yes, electric propulsion does solve that. And the question is, can we create a system that is both safe, reasonably priced, and cheap to operate so that it does compete with ground transportation safely enough and quietly enough? And I think, again, the place that makes this competitive, that really is the silver bullet for that industry, has to do with redundancy, simplicity, and supply chain. And that's more or less where, for me, AutoFlight was interesting. I've been following AutoFlight for years. I've known the founder. I've known most of the major investors, and specifically the team global lead, Lukasz Godowski and Tianyu, the founder, are kind of the two figures that I've been in touch with way before I got involved. And one of the things that were interesting for me was building on existing manufacturing capacity that's deeply embedded in the Eastern China supply chain on both the battery front, the motor front, and the composite front.
May I interrupt you here for a second? Because AutoFlight is a really global company. You have roots in China. You have an important presence in Europe, in Germany in particular, and you have your testing grounds in the US, I think in California, right?
Correct. So yeah, that's a fair comment, but that's really the point of the whole thing. So the way I look at it, and that was one of the things that I've personally pushed for in terms of the structure of the company, was that this needs to be built from the ground up as a design organization that's embedded and based, and today even is connected to the headquarters of the company in Germany, with clear line of sight to EASA certification and to how airplanes should be designed for safe operations, significant engineering and manufacturing capacity in China, so that some of the parts, some of the subsystems could be built at scale with, I would say, both a favorable cost structure, but also a favorable access to a stable basis of a supply chain that comes from the auto industry. Yeah. And then, of course, you need a foot in the largest market on earth, which is the US. So that combination is really, I believe, one of the unique selling propositions of AutoFlight. And that's how it's built. So the headquarters is in Germany. The design organization is in Germany and is in the process of being approved by EASA. The design of the aircraft is a joint effort between the German team that's doing the preliminary design and the let's say detailed design to an extent, and then the design for manufacturing done by the Chinese group then goes to manufacturing with a few components that are built specifically in each territory. So we will have, for example, final assembly facilities in Germany, and I believe longer term in the US as well, not only because of the geopolitical complexities of working with China and some aspects that are hard to develop jointly, specifically software and fly-by-wire systems, but also, and I would say strategically, mostly because of the differences in the certification paradigm between Europe, the US, and China. Okay. In a way, each right now has its own strategy, and it's unclear who's going to win. So you want to have the capability to have different flavors for the product as you go to market. And I think this is really the heart of what could make the eVTOL industry, I would say, competitive.
Okay, that's interesting.
Products in line for Europe, for the US, and for China.
Yeah, that's interesting because here on the podcast we've been talking with many entrepreneurs in the West, but China has also a very vibrant eVTOL scene that is maybe a bit self-contained. So it's active in China itself, but maybe not as well known outside China. And the companies like EHang and Volant and others. So it's interesting that you are in China, but also you are approaching the rest of the global markets.
Correct. So I think a solely Chinese effort would be extremely difficult. I think building an eVTOL is already very difficult. Certifying it seems like climbing the Everest at best, and doing this while being the only aircraft designed and built in China and then sold in the West is probably impossible. The reason, by the way, is embedded in the approach, in my mind, that the Chinese authorities are taking to certification, and in the absence of a general aviation market in China. So there are interesting opportunities in Chinese manufacturing, but I find the channels or the paths that regulators are taking right now for eVTOL operations and certification not to converge. So leaning on what China is in terms of certification, go to market of this eVTOL kind of emergence there, and using that for the West, I think is not feasible, mostly because the approaches are very different and the way this will operate is very different. Again, the airspace is unchallenged. There are no Piper Cubs flying with no electrical system that you need to think about, which is a mixed blessing, because on the one hand, it's easier. On the other hand, if it's so easy, you don't get the benefits for trying to operate in the European or American or global NAS. That's my take. And I think it is not extremely difficult at this stage because it's still kind of a bit nebulous. It's not completely clear what each regulator is going to demand. It's not very difficult at this stage to pick one, to slightly overshoot some of the requirements, and to, let's say, have a very calculated hope that this will cover most, if not all, of the requirements of both EASA, the US, the FAA, of course, and CAAC in China.
Now, the aircraft, because we have been talking about all this process, the structure of the company, but we haven't talked actually much about the aircraft itself. What can you tell us about the eVTOL that you are designing? What are the features? What's the performance? I read that, for example, you recently broke a record for the longest battery power flight. I think you did 250 kilometers or miles.
Yeah, 250.3, just over kilometers. And it was super exciting in the sense that it was a record broken. I believe that we're going to see a lot of those broken repeatedly in the next couple of years. I think it was exciting for several reasons, and I'll get to that in a second. But let's talk Prosperity One for a second. So Prosperity One, which is our manned prototype or passenger aircraft going forward, and it will have a cargo variant, but that's kind of the core of it. That's kind of the eVTOL people are looking at, is a lift and cruise configuration aircraft, all battery powered, of course. We have 10 lift rotors and a wing, and also 2 push rotors, so 12 motors altogether, flying at speeds of around 200 kilometers an hour, and range, as was demonstrated, of just over 250 kilometers. Probably can do a bit more, but you want to keep some of that reserve in the battery to be able to safely maneuver and land. The purpose of the flight test for that endurance record was obviously to reach that milestone and to open the envelope and to show that we can fly as far also to ourselves. But I think what's important to understand is that those battery-powered eVTOLs carrying around 3 to 4 passengers, depending on size. Again, we're sized to carry a pilot plus 3, roughly 2 metric ton of maximum takeoff weight. They can be built to fly a significant mission if they have a wing. So if you build a lift and cruise configuration, you can fly this far.
Can you explain what's the lift and cruise configuration?
Lift and cruise, meaning there is a separation between the lift system, a bunch of propellers that lift the plane up like a big drone, and the cruise system that is basically a fixed wing aircraft that pushes or tractors the airplane and then flies it while generating lift from a wing.
And how is that transition achieved? Is it the same engines or you use different sets of engines for each phase of the flight?
So that's the point. You lift with mostly with the lift rotors and just using the pushers for stabilization, and then you start pushing while still spinning the lift rotors, creating forward speed, and with this forward speed, gradually the lift transitions from being created by the rotors to being created by the wing until you get to a speed that's high enough to allow the plane to be supported by the lift generated by the wing alone. And then you stop and lock in place those lift rotors. And then when you transition back, you do the opposite thing. You slow down on the wing to the safest point you can still control the aircraft, start the propellers, and gradually move the lift from the wing to the propellers until you come to, basically zero speed in vertical, in the horizontal axis, zero forward speed, and you can maneuver again like a drone or like a helicopter. This is the idea of transition. The benefits of it as compared to other players is that there is no changing geometries. You don't need to have anything tilt or move, or no heavy and complex mechanisms that require a lot of rigorous testing to understand what they actually do to the aircraft. The saying is that in every 5 degrees of this tilt, it's actually a different aircraft, and you need to prove a lot of things are safe while doing so in transition of those geometry changing machines. Obviously, like in every other aircraft, this is always a compromise. So there are other issues. For example, those large rotors, the lift rotors, when you push them forward, they vibrate, and you need to mitigate that vibration. And there's a lot of fine-tuning and clever engineering involved in that. But again, assuming you did your job right and the engineers work hard as they did, and we did, and they did. I think what we can show is that much like, today, the only company that flew anywhere near this is Joby, that flew the previous record roughly a mile shorter, so very similar. And I think that's, and I think that's really the heart of what was achieved with our record-breaking flight. It's that if you build it right, and if you use the state-of-the-art technology, you can reach these kinds of ranges. So looking back at what we discussed before, what kind of mission are we hoping for? That's easy. We're easily going to fly a couple of, tens of miles. We flew 155 miles. That's a lot. You don't want to be an hour and a half in such a small cabin. You probably want to be able to fly this with a lot of reserve, so you know that you're fine even if there is a charging issue in the first landing spot you have. You probably want to fly this with maybe several hops, so you don't really have to. You can pick someone up and continue to your final destination. It gives operational flexibility, and obviously, if you want to fly 150 miles, you can do it. So, I think that's what we're seeing, and I think what it really says is that these planes, from an operational perspective and from a performance perspective, are ready for prime time with existing technology. We don't need some breakthrough in battery technology, motor technology. We're fine. Mm-hmm. We just have a lot of work to do in proving that these are rigorously built safely for prime time and for social acceptance. Mm-hmm. And that's really the heart of the next move.
Who is your primary market for this? Are you expecting operators to emerge, like, let's say, taxi companies, or private individuals, companies? What's the primary market that you're expecting? And do you have any estimate of the cost of operation and the, let's say, the retail cost of this? How much it's going to cost to get one?
So these are two questions for which I have, I would say, some answers, but a lot of it is yet to be seen. A lot of the players out there today are trying to be both the OEM for the aircraft and the operator, mostly because it is so difficult to prove a future market in an area that does not yet exist. And this is not a replacement for helicopter service in a city. This is potentially an extension of the taxi that takes you to the airport or something like that. And it's very hard to do the math. So for existing airlines, this is a little beyond the way they usually buy planes. And I think we're going to see a mix of operators emerge. Some of them are going to be either the airlines themselves or very, very strongly affiliated with the airlines. And some of them are going to be either completely new players or players who are today more intertwined with ground transportation that want to go in that direction. We do not intend to be an operator. AutoFlight is an OEM. We sell our planes, and we do have a few surprises up our sleeve that will be unveiled in the next couple of months and showing some deals that are happening. That said, in terms of price to operate and price for the aircraft itself, so we believe the target price for these things need to be just north of $1 million at the end. And I think we can reach it. Anywhere between $1 and $1.5 million per plane is doable with a very, very simple configuration as we've presented, and with a very well-built supply chain that's both vertically integrated into the organization, but also leans very heavily on existing manufacturing capacity in the auto industry or elsewhere where you're not vertically integrated. In terms of direct operating costs, the target here needs to be that in reasonable operating distances, meaning anywhere between 2, 3 to several dozens of of miles, I would say up to 50 miles, this needs to cost more or less in the order of magnitude of an expensive taxi. So the fancier taxi service, this cannot cost 5-6 times more than that. And if you do the math per seat, that means that your direct operating costs per flight hour need to be very low, need to be in the order of magnitude of $25 to $50 in direct operating, not including piloting and I would say insurance and some other costs that are there. Obviously, it differs from one market to the other, but again, looking at the simplicity of what we've built and at the maintenance requirements that it entails and the energy requirements that are involved with it, we believe that we will be able to offer a price structure that allows operators to really take you from Manhattan to JFK at the cost of Uber Black. Obviously, the same applies for LAX and anywhere in the Los Angeles greater metropolitan area or anywhere else in the States. The same goes for Europe. Now, to do so, and that's really the heart of the difference between AutoFlight and some other players that today, we can probably be the first one to do it out of the gate. We don't need to scale to tens of thousands of these planes in the sky to really get to those price points. And that has to do with the simplicity of the design and the vertical integration and embedded supply chain that we have today.
And in terms of time frame, where are you now? What's the timeline ahead? Do you have any expectation to get certified between a specific time frame and then to launch commercially?
So that's obviously the multi-billion-dollar question for everybody. I think putting a date on it is always difficult, and there will be significant surprises in the 2-3 years to come. We have created a very robust design that I believe is very close, but it's not quite the conforming prototype coming out of a conforming production line. And that's something that people need to understand. There is a process that does not only require to prove that the plane is safe, but also that the next plane is going to be exactly the same. So you're actually certifying both the product and its manufacturing process.
Because you have one prototype now. You've built one.
So today we're actually flying quite a lot of planes already. We have 4, I would say 3 really close to conformity prototypes, and we can fairly easily build more, and we are building coming constantly closer and closer to that point where we can say, okay, this is the conforming prototype. From now on, nothing in the aircraft or the process changes, which is really a significant milestone for us internally. I believe we will reach that milestone early next year. And from that point, you're probably looking at around 18 to 24 months of EASA certification. So we're looking at 2025, mid to end of 2025 as a reasonable time frame for EASA certification. Can it, or is it likely to slip by a year or two? I don't know. I presume, based on my experience with the aviation programs and with the, let's say, early stage of that regulation, that the regulator will have things to say that will be significant, and we will need to take them into account. Once that something is not completely in your hands, if there's one thing I learned from aviation, it's not just expecting the surprises. It's just understanding that in many cases, it's not just you developing, the regulator is also developing the regulation, and some things will change. I believe that looking at the bigger picture, having commercial operation of Prosperity One in both Europe and the US and China, with different regulatory bodies approving their own ops, is likely to be global by 2027-ish. Assuming we go to maybe China cargo first, just because it seems like it's a more straightforward mission, or more or less neck and neck between China cargo and EASA certification for passengers, and then probably a verification type certificate. So a type certificate that is done by reference to what we did with EASA with the FAA, no later than a year after that. So again, if the ambitious goal is 2025, I would say that between 2025 and 2027, you're probably going to see all of these come into place. And that's really what we're working towards with both the flight test campaign and the setup of the production and quality systems that are needed.
On your website, you mentioned that you are applying a whole set of novel technologies to the design of these aircraft. In particular, you mentioned things like artificial intelligence, I think automation. Is autonomous flight in the cards at some point in the future?
I believe so. And again, this looks a bit further into the future, because I think we're going to see 2 or 3 stages of these products going into market. First of all, this plane is built to be flown by a pilot in today's regulatory environment, with pilots that will have training to carry people. So they've had a lot of flight training and a lot of experience with both helicopters and fixed wing, and really comply with everything that you would expect to see. Now, the thing is that once you start acting and working, the next step is to see how you scale. And the scale really comes when you have more autonomy. We cannot expect to see hundreds or even thousands of these planes over cities without some level of automation of the safety and air traffic over that city. And that automation happens in 2 very different avenues. You need to make the airplane itself more autonomous. It will make more economic sense. It's in theory, it's even safer. We just need to build it that way, like to build the whole system that way. But it also requires significant steps in social acceptance. Are we quite ready for people to climb on board and see no one there and treat this like an elevator? I think this will take time, significant time, regulatory, technology, and social acceptance wise. I think we're looking at 5 to 10 years into the future after the start of operations. The other side that needs to be automated is air traffic control, which in theory is a bit easier because you don't really have the social acceptance piece of it. It's already happening in very big airports. There is a lot of automation around the queue of landing. But still, there is a very, very complex system in place that relies very heavily on humans judging and making decisions, and creating a system that transforms this while keeps some level of compatibility to the systems out there today and to the people flying out today is very complex. So I think these things will happen further down the road, but it's our job as an OEM in the making to make sure that we're both ready for it, and then sometimes even lead the charge for making this a reality.
What about industrial capacity? How many units are you expecting to build? provided that all the certification and design and testing stages go as expected?
So this is again one of the unique selling propositions of AutoFlight. We already have a very significant capacity to manufacture. This is why we build multiple prototypes. This is why we test and certify our own manufacturing processes. We already can build dozens of planes per year today. I believe by the end of this year, we'll be able to build hundreds of planes per year. And that's really the target as we go to market. Growing that to thousands will require some further investment, and honestly is probably best done once you have that traction from the market and market product fit really nailed down, which I expect will happen in any case in the first few years of operation. The way you transition from hundreds to thousands, though, again, is deeply rooted in how you build your supply chain, and some of it is already in place already. So I feel that we're very well positioned there. I feel that going to market with the capacity to build hundreds of planes is significant. We've seen some of the deals that were announced out there talk about numbers that are unheard of for the aviation industry. An airline saying, "Oh, we'll buy 1,000 of those if something goes right," is interesting. And how do you build 1,000 planes? How do you build 1,000 planes as a startup? And the answer is, well, you start early. So we've started early.
Yeah. So for people that wish to learn more about AutoFlight, maybe see some images, videos of, for example, these testing flights you've been conducting, which websites, online resources would you recommend?
So first of all, AutoFlight.com does have significant resources and links that you can look at. We also have a YouTube channel that shows some of those test flights, and some of them actually have full length, so you can see the entire flight, accelerated or not. It's a bit boring, but if you're up for it, go for it. Another fun way to engage, I believe, is just to wait and see and come to the Paris Air Show. So some shows coming up throughout the year, and specifically Paris. It's been a while since Paris was out with at full swing with COVID and all. So super excited to go to Paris again, and hope to see a lot of people from the industry poking around there.
Mm-hmm. Yeah, indeed. I'm possibly going as well. And I wanted to ask you whether we are going to see your prototype flying there.
So flying at the Paris Air Show is extremely difficult, and I believe this will not happen. But at the very least, there'll be some surprises. So stay tuned.
Okay. Well, in any case, hope to see you there. So wishing you all the best with this project, and see you soon then.
Thanks, Mikhail. It's great to talk to you again, and hope to see you soon in Paris and after. Thank you very much. Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much, and see you soon.